Salam sejahtera guys. Welcome to another episode of Divelog. I am Adam.
Hey, hi. Salam sejahtera. Selamat petang. Welcome back to the Divelog podcast. My name is Dicky. Would like to remind everybody, we need your support. I mean, we have been getting a lot of support. Yes, if you don't mind, just press that share button, notification button, subscribe as well. And if it's not too much to us, if we can get you to share this video or any of our videos to your friends. Yes, Adam. So we have been going diving for the longest time now. I think we meet a lot of people.
Yes, we do.
We meet a lot of people. They can be very interesting people, knowledgeable ones as well. We're very fortunate in this industry, right? Who do we have today?
Before I introduce her to you and the audience, I want to prepare you guys.
Okay.
Prior to this beginning of this recording, a few days ago, I went over and searched for this person's credential, and I came across her CV. Mind you, that CV, it was on 2018. So it was 5 years ago, 6 years ago.
5, 6 years ago.
I reckon now it's even more. Her credential alone is 10 pages long.
Okay, so that was 6 years ago. Interesting.
So it will take some time for me to introduce her to you and to the audience. She is an oceanographer.
All right, cool.
Graduated at Florida Institute of Technology.
Okay.
She went on to further her study as an ocean engineer in the University of Rhode Island. So safe to say that she's American. And then she got her PhD in physical oceanographer at the Oregon State University.
So ocean engineer.
Ocean engineer.
And then?
Oceanographer. And of course
physical
a master.
Oceanographer.
Yes.
Okay.
And a master at it. Her position includes an analyst, an ocean engineer, a researcher, a scientist, a lecturer, and of course now a professor. She teaches all around the world. It's not only one region, but all around the world, namely in the United States, at Germany, in Australia, China, and Malaysia.
Okay.
And she also collaborated with professors from Japan. And she...
Very vast experience, huh?
Definitely.
Living in many other countries. That would be nice. Cool.
She is the only person I know who has been to Antarctica.
Antarctica. Interesting. I want to hear more about that.
Yes. And mind me, 7 times.
It's a dream to be there. Even
7
one time.
times.
So she's been there for 7 times. Okay.
I've not even been to Ipoh 7 times, bro. She has been to Antarctica 7 times.
7 times.
As a slave.
So, apart from that, she's also an editor, a council member, treasurer, president and vice president of countless magazine, national and regional society. She likes to volunteer herself, doing what she can to the society. And also, of course, sharing her knowledge, which is why she agrees to come and sit with us here to talk about the ocean. More interestingly, she has the NASA Space Grant Fellowship recipient.
Wow. Okay.
So I take it NASA gave you money to do research.
No. At the last moment, they got this thing from NASA that they could have a space grant fellowship, and they needed a person to go in it. And because I'd done some remote sensing, they figured they could pass me off. So
Did you mention the word spaceship?
It was a scholarship. It was for satellite stuff. I did some remote sensing when I was working as an ocean engineer.
To end it, I would like to tell you guys her specialties. Specialized in modeling of internal tides and tidal mixing in the Antarctica and Indonesian Sea and the waters around Australia. Yeah, safe to say this is why she is here in Malaysia.
Okay.
So her work is actually near where we are right now. And also, she published over 40 scientific papers.
She's a busy person, huh?
As a scientist, 40 papers.
That's not very many. I think it's up to 48 now. And what we measure it is by H-index. That means how many people cited. My H-index is 24. That means I have 24 papers with at least 24 citations.
She chaired and presented over 100 conferences around the world.
Well, sometimes I did 2 or 3 talks at a conference.
Without further ado, I would like you guys to meet Professor Robertson.
Welcome, Robin.
Welcome. Thank you for having me.
It's a very exciting episode for me because we get to learn about the ocean.
Yes.
Most of the time during our scuba diving courses, we learn a lot about diving, we learn a lot about skills, but there's not a lot of knowledge in regards to the ocean. We do learn about the ocean, certain physical aspect of the ocean in order for us to dive better as a diver. But generally speaking, we do not know a lot of things that is happening in the ocean. And which is why we have Robin here today to talk about that.
Okay, so I've got a question actually for Robin. She is a very busy woman. How did it start for you? I mean, what made you want to do this?
When I was a kid, Jacques Cousteau was on the TV.
Okay.
And I thought that was so cool. I was reading all the books on scuba diving and ocean in the library. And I grew up over 1,000 miles, so 1,600 kilometers away from any ocean. I was in the middle of the United States and there was no ocean around. So I'm reading all these books in the library. And in the last chapter of one of these books was Careers in Oceanography. And I go, what? You can do this for a living? And I was like, I'm doing that. And I did it.
Okay.
And that's what I can say is now I'm retired is I've done it. And I've talked to a lot of people who wanted to be a marine biologist and they didn't do it. But I managed to do it. To me, it was success because I'm in a woman and a male. A physical and ocean engineering are both male-dominated
industry, profession. Okay.
Tell us about being an oceanographer. What is an oceanographer?
So an oceanographer is a person that studies the ocean. There's basically four flavors. You can be biological, chemical, geological, or physical. I first went for chemical because my father was a chemist, and he told me that physics needed really smart people, and the implication was you're not smart enough for physics. But sometimes parents aren't always right about these things. And so I thought, well, he's a chemical engineer. My brother's a chemical engineer, so I guess I'll do chemical. As I was in university, I decided I wanted to switch to physical, and I couldn't because Dad was not going to pay for another year of university. So, and you were going to get the same degree. It was just like having another minor. So I have a minor in chemistry. I've forgotten all the chemistry. I don't know anything anymore. And I don't know any of the biology. I took a lot of the courses for the physical oceanography just because I thought it was interesting. And they were hard. Fluid mechanics is hard stuff. All the ocean engineers were getting jobs, and none of the oceanographers, we weren't getting jobs. When the University of Rhode Island opened up their program to women, they took anybody who was female who applied. And they saw my resume, and they said, you come here. And I went there, and 4 out of the 5 of us got degrees. But as an engineer, you only get a master's degree. So I stopped then, and I was tired of being in university, and I wanted some money, so I started working. I worked as an ocean engineer about 9 years. I ran into the glass ceiling. I decided to go back for my PhD. So I was 36 when I went back for my PhD, and I think I was 42 or 43 when I finished.
What exactly does the ocean engineering do, and what kind of jobs do they do? Where can I go, and which company and stuff like that?
Well, until I graduated, 3 months before I graduated, there were a lot of ocean engineers on the market. Where we were getting jobs was the oil companies, because at that time they had offshore structures. And ocean engineers do corrosion, they do forces on structure, they do currents, they do waves, they do where pollution is going. So if you have a nuclear plant or you have a sewage treatment plant and it's dumping in the ocean engineers will tell you where it is. So really, ocean engineers really work close to the shore, and oceanographers work in deeper water in general.
Okay.
So I was going to go for my PhD in ocean engineering, but then the department at Oregon State told me that I had to do an undergraduate degree first in engineering. I said, no. He said, you get laid off. And I said, I've been laid off. So that's when I said, okay, if you guys are going to make me go back and pay for a year of schooling, because if you work as a graduate student, both for a master's and PhD, I earned money. Not much money, but I earned money. And and they paid for your tuition, and you earned subsistence.
And then what do you do after that?
After I got my PhD, I did what we call a postdoc. To move to the next step, you have to bring in funding. The catch-22 is you can't write a proposal without a senior person on it, because you're not allowed to write a proposal yet. And if your proposal is funded, they do not have to hire you to do the work that you
propose.
But usually they do.
Okay.
So I went and I applied for this international research fellowship, and I got turned down. And then I got a phone call, and they said, somebody turned it down. You're the next on the list. It was about 10 o'clock in the morning, and they said, by 2 o'clock, give us a budget and what you do. I had to look up and find out what I'd in 6 months. I didn't remember what I wrote it about. And I didn't know how much money. And she said, you write it for like $30,000, $36,000 and 42. So you had to hit that number right exactly. You're like looking at what you're allowed to spend money on, and you're Googling how much things cost. And it included a language course in German. I did that. Yeah.
Okay.
And that's why I was in Germany. I didn't teach in Germany. I taught a little in the U.S. I taught mainly in Australia and Malaysia.
Very tough, huh? She went and then she did it because of passion and patience as well.
Well,
that's
yeah.
what she wanted to do, and yes.
The failure rate for PhDs in my department and a lot of other schools was 75%. Because the professors are producing their competition.
Okay.
And you're cheaper than they are.
They said, no, we're going to scratch this one out, this one out, this one out.
They scratched
We need to keep
lot
our
of
jobs.
people out.
Well, interesting to know, huh?
It is, yeah.
I snuck through, and and so when I say I made it, there were obstacles along the way. There were people that helped you, and there were people that hurt you.
Yeah.
Yeah, it's normal. That's life.
Yes.
Safe to say that Robin comes from a line of smart people. Oh yeah, Robin, you did mention to me that you are one of the first females in your industry, right?
I was first female a lot of times. I mean, Ocean Engineering Department decided to accept women, and they were smart. They accepted 5 of us. So there was a critical mass that we became friends. I'm still friends with one of the women. Well, actually, I'm friends with 3 of the 5 women. One of them disappeared. One of them was myself, so I can only be friends with 4. So, and that was since 1977.
40, close to 50 years, eh?
The first women oceanographer
Ocean engineers.
in the world,
Ocean.
or is it in the U.S.?
In the U.S. and possibly the world. I don't know. I don't know about other ocean engineering programs, but that was one of the most prominent ones. But ocean engineering, it does corrosion, it does sound in the water, and one of the professors, he did sound in the water, but he then helped develop ultrasounds, which is sound in the body. And ultrasounds are used totally now for all kinds of medical reasons, and it's a really wide range of topics.
And recently we have a guest with us who is a marine biologist, which is Alvin.
Yeah.
What's the difference between an oceanographer and a marine biologist?
Most of the biological oceanographers don't study anything larger than a grain of rice. So they're big on bacteria and really small stuff. Marine biologists do study the things that you dive and look at. I mean, you're not looking at things as smaller than grains of rice because you need a microscope or something. So a marine biologist is looking at that, and they're more ecologically minded. So they're looking at the interaction of all the organisms and that.
In the water, yeah.
And the biological are looking at that too, but they're looking at small things. And small things can be important, like zooplankton, which are animals that float, but they change their density, and they can go up 1,000 meters. And so every 3 days, they go up 1,000 meters, they eat a lot of guys, and then they go down to cold water. And these are things smaller than a grain of rice. And they're doing 1,000 meters up and down every few days. They go down, their metabolism slows down, and there's fewer guys eating them. They're hiding down there, it's dark. And then they go up. You think about 1,000 meters, nobody dives that deep. These guys are doing it all the time, and they're smaller than grains of rice.
And also you study the physical aspect of the ocean as well.
That's what I study.
For example, internal tides and internal waves.
Yep.
Would you mind telling us a bit about that?
There are different density layers, and air has a different density than water. And so then when there's a pressure disturbance in the air, the water goes up, and this causes waves. Well, in the ocean, there's different density layers. If you have the tide with all these different density layers, and it runs into a seamount or sea ridge, then the bottom layers are blocked. So they go up a bit and then they bounce off. And this causes a disturbance everywhere up in the water column. And this happens every time there's a tide come by. So that's an internal tide. Internal tides, they break down and cause internal waves. And then internal waves cause mixing.
Okay.
And that's what we're interested in, because the one thing the climate models don't do well at all is mixing. And the reason they don't do it well is that you got those little critters going up and down 1,000 meters.
Yeah.
They're mixing. A whale's mixing. The tides are mixing. The wind is mixing. There's so many things that are doing mixing, and a lot of them are really small and hard to predict. And we can do a lot of things with the physical equations. We know the main forces, but we don't know how to put those in. So we estimate that. And that's what I worked on, was that estimation and how to improve that in models, computer models.
So internal waves means there are waves under the ocean and there are tides under the ocean.
Yep.
So initially I only thought waves happens on the surface of the ocean.
No.
Is thermocline
And you know,
part of waves?
Thermocline is one place the waves happen, but you know, a salad dressing bottle, and you wiggle it and you can see waves on that. And those are the internal waves, 2 different density layers. And internal waves are much bigger because the density difference is much smaller than that between air and water. So they're big. So we see 50-meter internal waves really all the time. And even I've seen 200-meter in data. In Australia, on the northwest shelf, the internal tides come in and they wipe out from the surface to the bottom. And these are density layers. So if you were, it's a tide, so it's going to take 6 hours. But if you put something at that density layer, it would go to the bottom and come back up. They believe that one of the U.S. submarines was sank because it was riding at a density layer, because they change buoyancy like we do, and diving. All of a sudden, an internal wave came by, and that density layer went down, and it went down to crush death, crush the submarine. 50 meters would take you down to crush death if you're diving deep.
But it's quite abrupt. So
Well, tide is 6 hours, but there's other waves. There's like rogue waves. I don't know if you know what a rogue wave is? So you get a rogue wave. You get in the ocean, there's lots of different waves, and they add up, and once in a while they add up to something really big.
But essentially, it is caused by back again to the gravity pull of the moon, though, right? Because of the changes of tide on the surface, makes the tide underwater, affects the tide underwater as well. Am I right or am I wrong?
Yeah. Up at the surface, the wind mixes everything up. Deep, it's what the tides are the main mixing. I mean, whales are mixing it too, but we think that most of it's done by the tides. And we think it's done by the tides in certain places where there's seamounts or something that comes up to the surface, or the continental shelf break where the depth changes.
Interesting that you said the submarine and so on. Don't they have anything to refer to, or is there a warning that can get with regards to these internal tides and so on, or waves?
Some mariners, they know some places that this happens. We can see in our model, especially in Indonesian seas, we can see places where it's going to be bad. That data is out there for them to see. And we have maps and saying, internal tides are big here. If you're just cruising along in the ocean, you don't know. And so I don't know if you are aware of this, but about 10, 15 years ago, a U.S. submarine was cruising along, and there was a seamount that wasn't mapped, and they ran into it.
Oh.
And several people died. And the submarine was severely damaged, but we don't know the depth of the ocean very well. That was the big thing with MH370, is that they mapped a huge amount of the Indian Ocean with that, because that was totally unknown. And we know the surface of the moon and Mars much better than we know the bottom of the ocean, and it's expensive to figure it out.
Are these information available for public to see or to refer to?
Yeah, it's published paper.
But where can we get them? I'm not aware of this information.
I'll give it to you.
Okay.
It's my work.
Okay. You won't be able to get it from NOAA website?
No, NOAA wouldn't have my papers. But it's I did that work a long time ago.
Okay.
I think it was published in 2008.
So, but it is still ongoing. So, there is a department that's looking after all these
There's
statistics
no
and
department.
information.
There's scientists. I wrote something and convinced the government, U.S. government, to give me money. And actually, that was the Office of Naval Research. And they gave me money, and I did it, and I published a paper. And if you collect data for that's the U.S. government paid for, it's online, and in Australia too. They just put lots of data out there. Anybody can use it.
Interesting, because she does a lot in our region, Indonesia, Malaysia, I would assume so, Singapore, all those area, right?
I don't dive in Singapore. That's a harbor.
Robin, why don't you tell us some interesting stories throughout your career? I mean, you have been to Antarctica 7 times.
Yes, I want to hear about
Exactly.
that, Lee. Are we going
Yeah.
to that now?
We can talk about it.
Okay,
No problem.
okay.
Okay.
What do you do in Antarctica? Why were you there for 7 years? And
I wasn't there 7 years. I
mean,
was there
seven
seven
times.
times.
So sorry, guys.
So-
7 times.
So the first time I went, I think it was 1995, and it was winter. So the sun doesn't come up at all. We went and we left Punta Arenas, Chile on June 22. So winter's just started. And we were down for 60 days. The piston on the main engine broke, and then we had to turn around and come back, and then we had to go back. That was through Drake Passage, the roughest seas in the world, 3 times in 15 days. But anyways, we got down there. And what we did was we set up an ice camp. They ran power lines on the sea ice. We were over 4,000 meters of water. We had little huts, and you'd walk out to your hut. They cut a hole in the ice, and we'd drop the instrument through the hole and bring it back up. And then the next hour, you drop the instrument through the hole and bring it back up. And you did this regularly for a bunch of days. Well, I was out on the ice, and all of a sudden, there's a knock on the door. There's a big storm, and the ice is breaking up. And
Oh,
they
wow.
said, you got to come off. I packed all the data and all my CDs, because it was 1995, we did CDs, throw it on my back and start heading out. I didn't take the instrument out of the water, because then I'd have to dry off the things, and the guys were not giving me very much time. But it was at the surface. You were wearing a T-shirt, but your feet were in ice. Your feet, there's ice on the floor, but you're wearing a T-shirt because the temperature gradient was huge in the hut, because it didn't have a fan or anything. Anyways, so we walking back to the ship, and the sea ice is, there's cracks in it, and you're having to jump over the crack. And when it comes together, you jumped over it and then walk to the thing.
Those
And
are
then-
experience, huh?
And then
I mean, a lot of load on you as
and the
well.
ship, the gangplank wasn't straight anymore. It was twisted, so we couldn't go up that. So then we had to get in one of the baskets, and you stand on the outside and you cross your arms and then lift you back on. That's an exciting story. That's the most exciting story I have. Well, one guy fell through, but
And he
he got
survived?
out. He got wet.
Okay.
Yeah, and then he was able to get out, and they let him go back to the ship and dry off really quick.
Okay, otherwise he'll
Oh,
get
yeah, and
hypothermia
then
and so on.
Miles McPhee, so the skidoos were going into the water, and Miles McPhee jumps on this thing, and he's trying to get it running, and the back of it's going in the water, and he guns it, and he brings it up on the ice. That was exciting. And there were a lot of people that say, that guy's got balls. You know, because, I didn't do that. I didn't drive the skidoo, so.
Have you swam at the Antarctic before?
No, we do the polar plunge.
Polar
You
plunge,
just
yes.
jump in, and you get out.
In and out.
How does that feel?
Cold. But then you go into the hot tub.
There's a hot tub as well.
Yeah, it's a thermal recovery unit.
Okay.
So you do it
only
several
do
times?
That, you only do that if you're at the station.
What is the water temperature, if you remember?
I know it really well. It's a freezing point of seawater with regular salinity is minus 1.89 degrees Celsius.
1.9 degrees Celsius.
So precise.
We had to know that.
And you went there 7 times. Over how long?
Went in 99, 2001, now 2000. I think I skipped 2001 because I was in Germany. Twice in 2004. And I went in 2000. Last time was in 2009. 4 times we went down, and we were trying to look at warming of the deep water. And we'd put in a mooring, and we'd take some measurements. Then we'd come out, but we went, and after the Larsen ice shelf broke up, we couldn't get into our instruments. And the moorings are down there, and you think the batteries are going to die. And the batteries on one of them did die, so that mooring is still there. It's probably got $500,000 of equipment on it.
Mm.
Nobody can get it. There's an acoustic release. So you put it down and you say, "Hi, you there?" And it says, "Yes, I'm there." You say, "Go to sleep." And it goes to sleep. And then you come back a year later or 2 years later and you say, "Hey, wake up." And it says, "Oh, okay." And then you say, "Okay, let go." And it lets go. And it leaves the weight on the bottom of the ocean. And all the stuff floats up. And then we're on the ship looking for
Trying to find it.
try to find it, and then we bring it in. But when the sea ice was too thick, we couldn't get there. So then we were worried because 2 years we couldn't get there.
You know, Dickie, every time I'm with Robin, we have all this interesting conversation about her adventures. There's one thing that struck my mind, like when she told me this, like, you know, on the research vessels, right? They are the scientists, and then they are the oceaners, the sailors,
The crew.
the crew that manage the boat.
And then there's the guys that work the instruments that are in between us because we're not supposed to talk to the crew
Yeah.
because we want to do crazy things.
Yes, that's exactly what I want to say. She is telling me that the scientists are actually the crazy people, and the crew are the buffer, the people that is trying to keep them alive.
The marine techs are
Yeah,
there.
because
Yeah.
it's for knowledge and it's for
Ah,
for everything.
yeah.
And you wanna push the limits, right?
Well,
You
and
know.
you think about the volcanologists. The volcanologists study volcanoes. They're always dying. The volcano's going to go off, so they go stand too close to it and with a camera, and then they get killed.
Yeah.
And they're doing that all the time. Well, some of the oceanographers are equally crazy.
But thanks to them. Without them, we don't have all of this information, and
Well, it depends if their instruments still worked or if the instruments are killed too.
But talking about the instruments and retrieving the instruments, there are, well, because of technology and stuff, there are methods, right? You can use ROV, cold water, diver, whatever.
In the Antarctic, I have never dove. What I heard is the viz is 200 meters.
Oh! That's super clear.
There's nothing in the water. It's the clearest water, especially if you bring it up from deep. Yeah.
Okay.
Yeah, it's really clear. Yeah.
Why don't we start with visibility? That's a topic that all scuba divers are interested in.
Yes.
It's always talking, how is
When
the
you go
vis,
there,
bro?
what's the vis? What's the vis today?
Yeah, when is the best month to go?
Yeah, stuff like that.
We measure that. But we don't call it viz. We call it transmissivity.
Transmissivity.
So we have a transmissometer that measures that.
Transmissometer, okay.
And it consists of, there's a laser and there's a detector.
Okay.
And they're held a little bit apart. I think about that far apart. And it just measures the percentage of light that makes it to the reflector.
To the other end, okay.
Yeah, and that's that simple. When you get near the bottom, it gets dirtier and the transmissivity goes down. And I'll plot that. That's one of the things I'll plot.
All right.
And if you get into productive water, visibility goes down. If you go into Antarctic water, visibility is great. It's 100%. Yeah.
What are the determining factors for visibility?
How much dirt is in there? So it's close to the bottom where things are stirred up. If you're in shallow water, things are being stirred up by the waves or currents. The general thing for sediment transport, like beach sediment, is that the waves pick it up and the currents move it. For a lot of the visibility is determined by biology. So how productive the biology is. If you want to have stuff there, you want some low visibility. The other thing is the deep ocean water. Deep ocean, I mean, it's like a desert so there's less life in the deep ocean. So when a current comes through from the deep ocean, like happened at Chebe last year, and we had 30-meter visibility. And I knew that this was great, vis-wise, but I also knew it was bad for the biology. But it's also good for the biology because a lot of times that has more nutrients in it, and the nutrients, and then everything blooms, and then you lose your vis.
So biology and particles. So when you talk about biology, are you talking about planktons? Are you talking about algae?
Planktons are anything floating. There's phytoplankton and zooplankton. Phytoplankton is plants and zooplankton is animals. The zooplankton eat the phytoplankton, but the whole food chain starts with phytoplankton. That's basically, I mean, there are little swimmers that can swim but it's not only plankton, but also, fish poop. that's in the water. And if you've got productive thing, then lots of things are pooping and making particles.
Okay. Maybe some of our listeners wants to also know why is it when there's mix of freshwater and seawater, the visibility change and the visibility gets poor, or there's a layer.
Well, even when you have temperature changes, it changes how the light propagates. So the light path changes. And even in these areas of upwelling and downwelling, when you feel the temperature change, you'll see the visibility goes kind of wavy. And yeah, that's saltwater and freshwater. The light propagation is different, so that
it's because of the density of freshwater and saltwater as well, right?
Yeah, and the density of the of the warm and the cold water. So same thing. But yeah.
Biologically wise, the stuff that is in the freshwater and seawater are different stuff as well?
Yeah, well, a lot of freshwater has a lot of nutrients in it because it's coming off, especially if there's any agriculture. It's got fertilizers on it, and that'll cause productivity. A lot of the ocean is starved for fertilizer or certain metals. A lot of it, we think, in the Southern Ocean is limited by the amount of iron. So some people have thought about taking iron pollutants and dumping it in the Southern Ocean to try to get more productivity to take the CO2 out of the air. Most of the CO2 that we've generated has gone into the ocean. So the Southern Ocean is south of 60.
It's absorbing all of that.
The device that you mentioned that measures visibility, it actually measures light. So is it safe to say that light plays an important part when it comes to visibility as well?
Yeah, well, that measures how much light comes out of a known source. But then we have this other instrument called a PAR, which stands for photosynthetically active radiation. So they only look at how much radiation is coming in from the sun or whatever that can be used by the phytoplankton or algae for photosynthesis. So there's a different instruments. Other than transmissivity, so Viz that we measure, the main things I measured and analyzed was temperature, salinity, and I did that to go for density. And I did a lot of density calculations in order to try to figure out the layers of the ocean, in order to try to find out the internal tides, internal waves. And we also would measure fluorimetry, which it says how much the biology that the phytoplankton are.
I've came across this article that discuss about visibility and recommendation for divers. Generally speaking, correct me if I'm wrong, Robin, okay? Visibility is better in the winter because the planktons and the algae blooms less because of the cold water. So there are less biological matters in the water.
I think that's true in the temperate regions. It's definitely true in the Antarctic when the wintertime has no sunlight. And the summertime, everything's going crazy because they've got nutrients and they got sunlight. But here, water temperature is almost the same year round. So I don't think that's true in the tropics.
Okay.
It definitely is true in the polar regions. In the temperate regions, there's two thermoclines. There's a permanent thermocline, about 500 to 1,000 meters. And there's the one that's shallower, that's called the seasonal thermocline. And that one develops starting in springtime when the sun comes out and it warms it up and it warms up. In wintertime, that goes away and it all mixes. There's more waves in the winter. When that mixes up, all the nutrients come up. And so in the springtime, when the sun starts again and all those nutrients are there, all the phytoplankton and algae just go wild. Then you have this spring bloom and you'll have no viz.
Which is why there are a lot of dive spots, especially in cave diving, right? Most of them actually prefers to go in the winter, even during the freezing cold water, because the visibility during winter is just much better. And also, visibility is generally better near the equator because of the amount of sun we get and also the angle of the sun. The light penetration is higher, thus giving us better visibility. So,
yeah, that'd be true. There's also upwelling and downwelling, and upwelling brings cold nutrients up, which as fertilizer, and then you'll get more activity. Downwelling is when the surface waters go down, and then you dive, you feel that as warm, but it won't be as much activity.
It is generally better to dive during high tide than low tide because high tide brings in water from the ocean to shore where we normally dive. When it's low tide, the tide will actually brings in a lot of sediments from the surface
Yeah.
to the ocean, so make the visibility much worse
Poorer.
and poorer. So it's better to dive during high tide. That being said, also it's better to dive when it's dry, when it's calm, not raining and it's windy. So basically, calm sea will produce better visibility. We are actually very fortunate to be near the equator.
We are.
Basically,
Because that's also where the corals are as well.
yes. Generally speaking, we have warmer water. We don't need a dry suit to go diving. We can just take our BCD, jump in, and that's it. There's not a lot of exposure concern. Visibility is actually much better near the equator compared to a lot of other places.
Yeah.
Except for Antarctica.
Except for the 200
200 meters visibility.
I want to go there.
But if you get there when it's springtime and the sun has just gone out, there's nutrients and all the phytoplankton go wild, and you're not going to get that 200 meters.
And how bad will it get then?
I don't
10
know. I
meters?
didn't dive, but
Okay.
yeah, we were measuring the CO2 concentration in the water, and generally it was around 360, but there it was 50. So it was
Okay.
really just sucking the CO2 out of the water, and then the air was giving more CO2. So that was good.
What type of animal or marine animal did you encounter while you were in Antarctic?
Whales, penguins, seals, and fish.
Polar bears?
No, polar bears are only in the Arctic. Penguins are only in the polar regions. Penguins have no natural enemies on land, so they're totally curious. Now, there's an Antarctic treaty, and you are not allowed to come within 10 meters of a penguin. Penguins are allowed to come within 10 meters of you. And if you sit down,
How do you do that?
if you sit down and hold your camera up, they will come right up to it, like right up to
And
it.
that's fine.
And that's fine because you're not moving.
Okay, but the predator wise,
What eats the penguins?
Yeah.
Killer whales.
killer whales, so they are
And
in those
leopard
regions.
seals. The leopard seals will eat you too. And the killer whales will eat you too. And the killer whales, they work in packs. One will spy hop out, and the other guys will be under the water here, and the seals will see the one, and they'll all go in the water where all the other guys
This
are
guy
waiting.
is gonna go.
Yeah. Or they'll even flip over the piece of ice that the seal's on, come up and bump it. And
Have you seen any of this action while you were there over that 7 times?
We definitely see killer whales. I didn't see them do either of those two actions. But we definitely saw a lot of killer whales. We saw a lot of humpback whales. And sometimes when we were putting instruments in the water, they're curious. So they came up, what's this? What's going on here? Penguins, we saw a lot of penguins. And they look kind of like ducks in the water until when they're on the surface. They swim really well. And seals, we saw lots of seals.
Would that mean that there's also the great white shark there?
Well, there's great white sharks in Australia, definitely. And also in Florida, where I learned to dive. I think the water's too cold for
Great white shark.
great white sharks. But there's enough things that'll kill you down there. Oh, there's elephant seals too. They won't kill you, but unless they sit on you, and then you'd be dead for sure.
So leopard seals, orcas.
Yeah.
What was the other one that can kill you?
Temperature.
Temperature, for sure.
But mainly the leopard seals, we were afraid of those. Because if you were going down to do the polar plunge, you want to make sure they weren't anywhere around.
Going to these places, it's not accessible to anybody except if you're doing studies, research, right?
Not
No?
anymore. Now, if you
Okay.
pay money, they'll take you down there.
Okay.
There are cruises to Antarctica now.
In 2000, I think we were on a cruise where one guy, it was really good. We got to go to all the tourist places like Deception Island, and he was taking water samples and seeing if there was red tide. And they thought that the red tide was coming down with the tourist boats.
Did you say red tide?
Red tide, they're called HABs for harmful algal bloom. In a lot of places, when there's a harmful algal bloom, it's red. If you eat shellfish that have eaten that, then you can die, or you can get brain damage. Or
Recently, we have that problems along Malacca Straits, right? All of those areas has this problem with cockles and oysters and all that kind of stuff where
yeah,
people get sick when they eat them.
Yeah.
So it's mainly due to the fact that the ships that comes from somewhere else dump their filter water in Malacca Straits.
It could be.
Or
The
maybe
Malacca-
there's...
yeah.
Or is it also grey water that they're dumping
Probably
in?
not, but well, yeah, they'll dump gray water, and the Malacca Strait's the busiest shipping channel in the world, and I don't remember how wide it is, but it's not very wide, and it's not very deep. I think 40 meters deep, and so that's not very, very deep. So you got this small water channel, and there's lots of ships going through, and they're dumping stuff. Most of the harmful algal blooms come from the tropics.
Robin, how does tide works?
The sun and the moon pull with gravity. The gravitational pull works on mass, which the sun has more than the moon, but it also works on distance, and the moon is much closer. So the biggest tide is caused by the moon. So when we analyze for the tides, we analyze at different periods. The 4 biggest periods that makes up about 75% of the tide, and we use 88 to get about 90%. But there's 180 of these periods, and some are like 2 weeks and some are a month long. But the main ones is the M2, happens twice a day. That's why it's called M2. It's caused by the moon, and its period is 12.42 hours. The K1, which is caused mainly by the sun, and that's period is somewhere around 25 hours. I don't know that one. This has to do with the rotation of the Earth. You add up all these periods, and they're all a little bit out of phase, but once in a while, they're all at the high at the same time. And then you get the spring tides. And every 14 days, at the other time, the M2 is high and the K1 is low, and they cancel each other out. You get the neap tides, and so the tide doesn't change very much. So neap tides happen when the sun and the moon are pulling in 90-degree angles. So sun's pulling one way and the moon is not pulling in the same direction.
Not even the opposite, but it's just, so it's 90 degrees.
When the sun and the moon are pulling either the same or opposite, which is new moon or full moon, then we have what we call the spring tides, and those are the big ones.
Questions that I have. We know that the sun is bigger than the moon, and we have the earth, right? But the moon is closer to the earth.
Yep.
So first, the question is, how big of a gravitational pull does the sun has, and how big is the gravitational pull the moon has?
The moon is much, much smaller, but the distance is much, much, much closer. And the distance goes as a distance times distance, which calls a square. So that distance, moon has much bigger influence
Gravitational pull
than the sun does.
The sun, okay.
Now, some places you get 2 tides a day. I think here's one of them. But some places like the Arctic and the Antarctic, they usually only have 1 tide a day.
Oh, there's places where you can get 4 tides a day, right?
Yeah.
Okay.
And that's other constituents adding in. You got all these 180 different times, what we call a period. So the time from high tide to high tide. Or from high on that frequency to high on that frequency. So then you add these up, and that's why it's all uneven. And that also is why there's king tides. Twice a year, they're super big.
I read that the moon is the main drive for the ocean tide, but the sun determines the tidal range. Tidal range as in how high and how low the tides are. No,
it's the moon.
not really.
It's still the moon, I think. And what really does is when all these guys add up and when one isn't high and one low, but they're all high, that's really going to be your big spring tide. Big king spring tide.
So judging from what...
King tides were big in Australia. Everybody knows about the king tides because one of the ships got blown during low tide, and during a king low tide, it got grounded. And they had to wait until high tide and really high tide to pull it off.
When you say king tide, does every shoreline experience this? No. It's only mainly in Australia.
I don't know. I heard
else?
about it mostly in Australia. They were big on king tides. King tides only happen twice a year. One of those 180s is like 6 months, once a year.
So when that happens, Australia is in that trajectory. Okay.
Is there a place in Canada? I read that the tidal range is so high that the high tide and the low tide difference goes up to like 20 over meters difference. Over here for us, it's only
2 meters,
3 meters,
3 meters,
4 meters, like
maximum,
that. But over there in Canada,
It's in the Bay of Fundy.
yeah, exactly. That's the
Yep.
place.
Bay of Fundy is on the East Coast.
How is that possible and what contributes to that? How is it that certain areas in the world experience very little tide changes, but there are also other regions in the world experience great tide changes?
So, well, the Bay of Fundy is a different story. But the answer to your question is when these things add up, and so they have characteristics because tides propagating around. Sometimes it depends on how deep the water is. Some places, as water depths, they slow some of the waves down and they cancel each other. And some places have something called resonance. And the Bay of Fundy has resonance. There's a natural frequency to everything. That's how a microwave works. It hits a natural frequency. It sends microwaves, natural frequency of water, and it excites the water molecules and then things up. And if you hit that resonance, it's like when you push on a swing, it gets bigger. You push at the right time, the kid gets bigger and bigger and higher, right? And you're hitting the resonance. Bay of Fundy is resonant with M2 tide. The tide pushes in and then it's reached an equilibrium where the friction balances the forcing. But it's just like that swing. It keeps pushing at the right time and that swing keeps going up.
Okay.
And it doesn't go any higher. It can't go any higher, but it's at where it's... They want to use that for tidal power, but there's a lot of problems with using tidal power is because of all the stuff in the water, and seawater is really corrosive, so it corrodes the equipment. But what they have been able to do is just wait for high tide, close something off, and then wait for the water to roll out and use that as like a dam. I mean,
it's not that flappy thing that they put on the water surface.
Oh, they can do flappy things too. I've seen a lot of designs, but that's an ocean engineer thing for sure.
And at the Antarctica, the tide range is just only centimeters, right? The difference between high tide and low tide. I don't know if it's Antarctica, but it's somewhere near there.
There's places where the tide hardly changes everywhere, and these have a name. They're called amphidromic points, and if you get the amphidromic point from one constituent, from M2 and K1 to get close, then you're not going to get any tides. We've got 2-meter tides in Antarctica for sure. That's what I did my PhD thesis on, and we have tides there.
There are actually places in the world that the high tide and the low tide is just almost the same all the time.
Yeah, South Australia is that way.
They don't know whether it's high tide or low tide because it's almost the same all the time. Interesting.
And then there's other places where it's huge. There's a place in Australia where 8-meter tides near Darwin.
And Luke, one of our South African instructor, he mentioned to me that Cape Town has 4 tides a day. And it's very hard to go scuba diving there because the current is just ripping. The tide change every 4 hours.
This topic is a little bit difficult for me because... It reminds me of my father. My father he's a naval officer, so he always shares his experience going here, going there with the tide and so on. When you are telling me all of this, it's like me looking and reminds me of my father telling me all of this.
I'm very surprised that I remind you of your father.
No, I mean,
It's okay.
Anyway, yeah. I got another question with tides. So we have tides, normal months of the year, and then when we have got the monsoon coming, the tides normally come up higher. Plus with the wave and the rain, maybe due to the winds and so on, so the waves hit or crash onto the beach harder and comes higher and so on. How is that during monsoon season we have higher tides than non-monsoon season?
I'm actually not really sure, but from what you say I know the monsoon has high winds, so there's something called a storm surge.
Okay.
And so when the wind blows hard, then usually during storms, there's 2 things. One is the pressure, air pressure is lower. So when air pressure is lower, sea level goes up. And the second thing is it blows the water on. So you have a double whammy there.
So the water is always being pushed to the beach,
So
and all
the ocean actually goes up, level goes up and goes down with the atmospheric pressure, but not so much that you notice so much, except when there's a storm and there's flooding. So storms are low pressure, so it's coming up a lit, and then there's all this wind blowing more water on, goes up more, and then the waves are bigger, and everybody gets flooded.
There you go, guys. I hope it answers the divers out there why when you are here diving and it's different, the tidal is different and so on and so forth. Yeah. Thank you, Robin. What do we have next?
Currents.
Okay.
Hey guys, thank you so much for watching to the end of this podcast. Please do go to our episode list to look for part 2, or you can enjoy any of the available content right now. Do comment below and tell us what you think about this episode, or you can actually give a suggestion on what we can talk about. I'll see you guys soon. Stay tuned. Here's a preview of the next episode. A lot of the customers actually sometimes ask, where are we going tomorrow? Where are we going the next day? Like basically choosing of the dive sites.
The average depth is 4,000 meters. And the deepest is the Mariana Trench.
Has anyone been to that depth?
We only have access to 1.2% of fresh water in the world.